Oh yeah, I hate C38.
No. Okay. I'm going to do one of them, but I'll tell you real quick for each of them. For number 2, you got to use AC method to factor the numerator, and then factor the denominator normally. For 3, you got to take out an x, and then it's very easy actually. Look at the top. Doesn't the top have an x and everything? Yeah. If you factor an x out of the top, up here it's very simple then. You write down x squared minus 3x minus 10, and then factor this into its factors, and then factor this one into its factors and cancel. So I'll leave that one for you to do on your own. But just know that you need to take out a GCF. Remember, every time for these problems we're doing, it's always GCF, then factor, and then simplify. Remember that order, please. A lot of you are trying to factor before you take out a GCF. And if you try to factor that, it's going to be really messy because you have x cubed. Or sometimes there are cases where everything is even and they're all like 2's. You can factor out a 2 first and then just factor normally instead of using AC method. Again, a lot of people are trying AC method when you don't need to do it. But for number 2 here, you have to use AC method because I cannot factor anything out of there. If, perchance, say this numerator had been that, then what can I take out of everything? A 2. And for this one, you would take out a 2, and then you would factor it after that. Or at least you would try to factor what remains. Again, remember, whenever you have a problem, start with the GCF. On every single problem we do, every single one, no matter what topic, if you're trying to factor at any point, you always start factoring with your greatest common factor, and then you try to factor the quadratic that results from that. Again, you start with a GCF, then you factor what remains. So here, your GCF is x, and then you factor this into its factors. Minus 5 and plus 2, you'll see that's what will come out there. Okay, that makes it a lot easier on yourself. So now you have, again, you can cross off this line here too. That's what your new numerator is right up there. So always GCF, then factor, then simplify.
But for stuff like...
We're going to do it.
Oh.
We're going to do AC method now. So that's what we're going to do now. Oops. For this one, if we want to do AC method, again, this was not the problem. This was just another example. For AC method for number 2, what is AC equal to? What is it? 70, or we should really say negative 70, right? I'm going to zoom in to give us more room. Okay? So in this case, AC turns out to be negative 70. B is 3. That's the numerator, right?
Yeah.
For AC method. So, what numbers multiply to negative 70 and add up to 3?
Yeah, I had it.
Nothing at all?
7
I think of one right away. What is it?
7
7
and 10.
and 10. 7 and 10 give you 70, don't they?
No,
And can't 7 and 10 give you 3 somehow?
Yeah.
Because 10 minus 7 is 3. So I think of this as a positive 10 and a negative 3, a negative 7. Because of what I want as my result is a positive 3. So those two numbers are numbers that multiply to 70, negative, and they add up to 3, positive. Okay, again, those are my numbers. Now, those are not the roots though. You have to actually do AC method. So go ahead and rewrite your quadratic from the numerator. But in here, put 10b minus 7b minus 35. That's the key here. These are not your roots. A lot of people confuse that. They get these answers, they say those are the roots. Because in the original way, when we factor, those are the roots, or those are the factors, rather. But here, we have to then use AC method. So we must factor by grouping now. So please group. When you group the left side, what's the GCF on the left side?
2.
2.
2B.
2b, or not to be, either one. Come on, nobody? All right. So when I factor out 2b here, not just 2, because a 2 comes out of both for sure, but there's a b squared here, and there's a b there. So make sure you take a b out also. Who remembers, in case you forget what was left over, how do you do that again? By what? Good. In your mind, this is what you need to be doing, if you forgot. 2b squared over 2b is just b. 10b over 2 is just 5. So if you ever forget what's left over, just think about always dividing by the GCF. On the right-hand side, if I want to get b plus 5 here, because I know that those have to be the same, what must I take out?
Negative 7.
What is it?
-7.
-7. That's the tricky part of this problem. Because look, you want to take out a 7, don't you? But notice they're both negative here, but we want them both to be positive. So we must have to take out a -7 here. If I take out a +7, this would be -b minus 5, which is not the same as b plus 5. And we know that this must be the same as this for this method to work. And as I know, the remaining, whatever's left over here, I'm going to see is my factor. So 2b minus 7 and b plus 5. Again, how do I get that? I take the coefficients, or the GCFs, I make them one of my factors. I take whatever repeats itself, in this case b plus 5, and that becomes the other factor. Now that's my numerator. So go ahead in your numerator, cross it off. You did all this work. Cross it off and just write it up here to start. 2b minus 7 and simply b plus 5. B's and 6's look very similar. I will try not to use a b as a variable from now on. I didn't think about that. But when you're doing your work, be careful. Be careful. A lot of people think they're 6's when they're writing, and then they see like, oh, 2b, and that really looks like 26. Okay? It does look like 26 if you look at it real quick. So be careful when you do this. Denominator, what do you get? 5 and 4. Notice, the 5 repeats itself. Is that a coincidence? Maybe, but I kind of made the problem that way, right? If they didn't repeat itself, could you simplify?
Yeah.
No, you couldn't. So you have to. Again, simplify by canceling, and your final answer is 2b minus 7 over b plus 4. Again, whatever results in the answer is what's left. If you have a problem on the SAT and it says simplify, and for some reason you don't get the same factors up the top and below, you must have made a mistake. Because if they say simplify, something must simplify. And in this case, the b plus 5 is what's simplified. Again, if the problem says simplify it to its simplest terms or lowest terms, something's got to cancel, and these two canceled. If they did not, then there's a chance that maybe you made your factors wrong. Maybe you made them plus instead of minuses, so go back and check. Okay, use that as a bit of a context clue when you're solving these problems. So that's for concept 38, which is simplification. Okay, concept 39, it's the same thing. Concept 39 is simplification, but you just got to factor everything, and then you can simplify crossing or above and below. 39 and 38 are identical. Again, I'll say it again. You don't need an LCD here. People are trying to find LCDs. This is multiplication. It's like taking my fraction line. This is what multiplication is like doing. And it's like extending the fraction line like that. That's all that it really is. But I can't cancel anything because nothing repeats itself. So now I need to start factoring. So if you see multiplication as a problem, think about concept 38. It's just simplifying. That's all it is. Division, you just have to remember to flip the right fraction because you're multiplying by the reciprocal. But for multiplication, think of it like this, please. This is number 5 here. What does x squared minus 16 factor into?
X plus 4, x minus 4.
Good. X plus 4, x minus 4. What does this upper right trinomial factor into? Minus 9 and plus 10. Very good, Andy. So look at the factors you have up top now. Don't you have 4 of them? Because I had 2 quadratics up top. Remember, I had x squared minus 4. I'm sorry, I had x squared minus 16, which reduced to x plus 4x minus 4. That's 2 factors. And here's the other 2 factors. What do you think about the denominator might happen here? What might happen in the denominator? It's only going to be 3. Very good. Because here's one of them. Again, x minus 9 is one of them. And then I have 2 others. But what do you notice is already happening? They're going to cancel the minus 9s. X minus 9 is there. What does this factor into?
X plus 10,
X plus 10?
X plus 4.
Plus 4. Good. Plus 4. Be careful there. So start canceling. Cancel, 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 cancel. So what's left? X minus 4 over 1. But do I need it over 1? Okay, simply x minus 4. So remember, when you multiply, a lot of you guys are trying to find LCDs and stuff. That's only for adding and subtracting. You never need an LCD unless you're adding or subtracting. So here we are multiplying. So remember, think of it as one giant fraction for multiplication. Okay, again, the 10 canceled with the 10, the x minus 9 with the x minus 9, the x plus 4 with the x plus 4. Clear? Division. Any different? No, but let's take a look anyway, just to verify that we're correct. What about number 8? Did anyone get to number 8?
Oh, that was.
Number 8's a little bit trickier than 7, actually, I think.
I did not get that.
7, the whole idea for 7 is this. I'll give you a hint. You got to take your GCFs out or this isn't going to work. Here I see that there's a 10 in both of these terms. There's a 10 in both of these, really, and there's an x in both. So your GCF is 10x. Here, your GCF is going to be 40x squared.
Can you
Again,
write it?
40. You want me to just go through this problem? Then I'll leave you number 8 to do. I'm not doing both. Okay, so we'll do number 7 together then. So let's go ahead and do number 7 then. Now, with number 7, the first thing you're going to notice is the following. It's division. So what must you do?
Put the reciprocal.
Good. Multiplied by the reciprocal. So you could start by rewriting this over here as 10x squared minus 20x all over 40x cubed minus 80x squared times the reciprocal. 16x cubed plus 80x squared over 6x plus 30. Now I'm going to go over here with this. Okay, again, multiply by the reciprocal to start, please. After that, look at your GCFs. So I'm going to take a 10x out of the top because I see that there's a 10x in both. Here's the 10 in both. There's an x in both. What remains is simply x minus 2. Okay, how do I do that again if I'm on a check? Okay, multiply back out to get there. Good, that's one way to do it. Or you could look here and say, if I take a 10x out of here, I want to really be thinking about this as like dividing by 10x, dividing by 10x. If you did that in your head, 10x squared over 10x leaves you behind that x right there. 20x over 10x leaves you behind a 2. Well, there's a minus sign, so I carry on the minus sign. In the denominator, what's my GCF here?
40x squared.
Good. There's a 40 in both, and there's x cubed here, but there's x squared here. So there's only x squared in both. There's not x cubed in both. So I start with a 40x squared, and look what's left. X minus 2. Wow, that's pretty convenient, isn't it? Next, on the right-hand side, what comes out of 16 and 80? 16 does. That's the tough one. 16 goes into 80, actually, 5 times. Okay? And you notice that there's x cubed and x squared, so at least x squared is going to come out. So I take a 16x squared out, I'm left with x plus 5. What do I take out of the bottom, guys?
6.
What's left over if I take a 6 out? Another nice occurrence. Okay? At this point in time, start canceling. That's all you got to do. Cross cancel, vertical cancel. X minus 2, x minus 2. Done.
And yeah, wait.
X plus 5, x plus 5. Done.
And then can you take out those x's on those?
Yes, so I could take one of these x's with this x squared, or I could just see, look at the x squareds, aren't they in both?
Oh, okay.
Cancel this x squared with this x squared right here. And you could have done it the other way. You could have reduced the left-hand fraction first. You'll get the same answer either way. Okay? Again, you could have reduced this one over here. You'll get the same answer either way. What's left, though, to do is to take a look at my my numerical fractions now, because those can all simplify. What's 16 over 6, really? Ooh. 16 over 6? 16 over 6 is 8 over 3. Reduce them both by a factor of 2. That becomes 8 over 3. I'm making lowest terms my fractions. What's 10 over 40? 1/4. So I'm going to put a 1 here and a 4 down here. And what you're going to notice is, now I have 8 and a 4, don't I? See the 8 on the upper right and the 4 on the lower left? So I can simplify those further. What does that become? 1 and 2. The third will carry down, yes. But this becomes a 2 now. This becomes a 1 down here. I'm cross-canceling now. And when I go back and look, I see, well, I can't forget about this x that was here. I have that x still. Don't forget about it, please. But beyond that, in the numerator, all you have left is 2x. And what about the denominator? What's left?
3.
Just a 3. So your final answer is 2/3 x, or 2x over 3. A lot of work to do to cancel here. Notice this complex problem we had that resulted to something as simple as 2/3 x, or 2x over 3. Remember, you can write it like this. You could also have written it like this. Okay, that's the same thing. 2x over 3 or 2/3 x are identical. Either one. So look at the problem we had just now. Think about this as an SAT kind of problem. These choices are not very apparent. There's a good chance that they'll pick numbers that make all the common mistakes as their answers, and this will only be one of your choices. One of them, obviously, not both, because they're both correct. Okay? It's not always apparent just by the problem what the answer will look like. Very complicated problem, very, very basic answer. Number 8, my suggestion to you is, again, take a look over here at your GCFs. Start with your GCFs, it helps a lot. Next, concept, I think 40 or 39? 40.
No.
All right, concept 40. Numbers 9, 10, or 11. Numbers 9, 10, or 11. Which one do you want to do?
No, wait.
11.
Here are 10 and 11. Let's take a look at both for a second. 10 is that one. Okay. And 11 is that one. Okay. Now, suggestions for 10. Remember, you need an LCD here now because we're adding and subtracting. For 10, I would recommend you factor. I would recommend that you factor to start this problem. Again, how come? Because it doesn't look like there's any common denominators at first, but if you factor both of those, you're going to, and I'll leave you with this because I'll go to the next one and perform the next one. But you're going to see that you have this. You have x plus 2 and x minus 2 for this factor. And for this factor, you're going to have x plus 5, x plus 2. So for this kind of a problem, you want to see that x plus 2 occurs in both already. Okay, that will help you with this problem. I'm going to solve number 11, but keep that as your starting point for number 10. Okay, again, remember to factor to start. Let's go to number 11, though. All right, number 11. Looks complicated at first. It's not that bad. Here's what I would recommend you do. Factor first, as always. What does the 2d plus 6 come into?
2d, 2 parentheses d plus 3.
Very good words. Very good words. Way to use them right. Good job. Please, 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 make sure you go ahead and do this. It helps a lot. Factor as far as you can, even though you're going to think right away it doesn't help you. Okay? Factor as far as you can, please. Now, what's missing in this one on the right? D plus 5 only. Again, on the right, on the right. Only the D plus 5 is missing. On the left, though, Diana, tell me what's missing over there. Very good. We're missing a 2, and we're missing a D plus 3, both. So I have to remember that I'm missing a 2, and I'm missing a D plus 3. A lot of you guys are forgetting about the GCF you take out. If you have a 2 here, you've got to remember that it's got to appear there as well. Now, please listen carefully what I'm about to say next, because everyone is making this mistake. You can't cancel your denominators. This is not solving an equation. This is not simplifying one of those complex fractions. This is like saying the following. Eddie, what is 1/5 plus 2/5? How many fifths do I have total? Did you drop off the 5? So you cannot drop off your denominator here. Whenever you perform these operations, and I'm going to write, perform the indicated operation, because I want you to remember what to do. Here, this is addition. When you have addition, you combine your denominators into one, like we did up here. Okay, this is not an equation. Actually, I should really write this as an arrow, because I'm reducing 1/5 and 2/5 together to become 3/5. It's not really an equation. An equation really only exists, or is really only useful when you have an unknown variable you're solving for. Here, we're not trying to find the value of d, we're just simplifying. That's all we're doing. So in this case, I want to write my denominators together now. So write it as one denominator. And notice, I don't care about the order of the denominator. I could have written it as the left one or the right one. I wrote it even differently. All I wrote, though, was everything together. It does not matter the order of them. Now in your numerators, what should I do? What does the 5 times 2 come? Please make this a 10 to start. Cross those off, and now you know you can distribute the 10 to both. Okay? And a lot of you ask this question, which one can I do first? It doesn't matter. If you were to distribute the 2 and then distribute the 5 after, you would still get 10d plus 30. But my recommendation is always, always, always multiply your numbers and then multiply your binomials. Okay, use your numbers on the side and your binomials together. Over here, what do I get?
Plus 4d squared plus 20d.
Well done.
But then you have to do this.
What do I have to do now?
You should
You leave, don't touch the denominator. Leave it alone.
Yes, you just
Add
do
the
like
10d and the 20d.
Good. Like terms, just like terms. So the 10d and the 20d, really. So rewrite this as 4d squared plus 30d plus 30.
30.
Then
Yeah,
you break it
times a
down
D, yeah.
Why can I break this down further, Andy?
so you can simplify with the number.
Absolutely. So what comes out of the numerator?
4,
Be careful.
you know,
What's the GCF of the numerator,
40.
guys?
No,
2.
Only a 2. Be careful. Look at all your numbers. Is 30 divisible by 4?
no.
30's not. It's 8.5. So you can't take out a 4 here, but you can take out a 2 out of both of these. Is there a D in everything?
No.
So you can't take out a D. So all you can take out of the numerator is a 2, but that's convenient because it's going to cancel with the 2 down at the bottom. So reduce the numerator into this. Okay, reduce your numerator like that. So I'm going to put a line through my numerator because I've rewritten it. And now I'll see that this 2 cancels with this 2. Very convenient that those cancel. In the numerator, the question becomes next, can I factor this to see if one of them will cancel down here? I should check. I should check though. What's AC method tell me about this? If I use this one and look at AC method, AC turns out to be 30, and then B turns out to be 15. Are there any numbers that multiply to give you 30 and add up to 15?
Oh, wait. No, 15 and 2. Oh, no, never mind.
No,
Say
no.
my bad,
Oh.
bad. No.
Let's look at the factors of 30 if you don't know. 1 and 30, do those give you 15?
No.
2 and 15, do those give you 15?
No.
3 and 10,
No.
4 doesn't work. 5 and 6, does that give you 15?
Nope.
You're done, that's it. Once you get those numbers so close to each other, like 5 and 6, there's no more factors left. So AC method fails here. So what that means is my final answer is simply whatever's in this right here over this. But again, you can leave this in factored form because there was a chance that if AC method did work, maybe one of those factors would have canceled one of these denominator factors. So you always have to go back and say to yourself, if AC method works, or if I can factor the numerator any further, it might cancel. It might cancel. But in this case, it doesn't. Now, this is one of my answers. So again, the answer that we get from this problem is this 2d squared plus 15d plus 15 all over the denominator. What's another way I could have written it out? What can I do with the denominator, really? I could FOIL it. I could FOIL it. I'm going to leave it like this. So I'm going to leave my answer as 2b squared plus 15b plus 15 all over. Oh, is it b or d? I'm saying d. It's d. Does it matter, really?
Yes.
Yeah, I know it does, but it kind of doesn't. All over d plus 5, d plus 3. And again, I would write that as my final answer. If you're taking the SAT and you notice that kind of choice, maybe you have to distribute the denominator out to see what's left. Okay, to see what's left as your other choices. Maybe that would work. But again, remember here, if you want to write a big note in big letters, don't cancel the LCD. You're not canceling it, you're carrying it over. You're not canceling, but carrying it over. In the next two concepts, you can cancel it. And we're going to explain again how come we can do that. Okay, but again, you can't cancel the LCDs here. Next concept, which is 41? 1, okay. 41, we have 12, we have 13, and we have 14. Lots to do here. I'm not going to do 12, I'm going to quickly discuss though. 12 people got confused now because they were numbers suddenly, and there were no variables now. We did this to start class. Your LCD here from all these four denominators, what is it?
36.
36. Again, take a look. This would be missing a 9. This would be missing a 3. This would be missing a 2. This would be missing just a 1, which is not really there. At that point in time, you can continue the problem. But again, you need to have an LCD for these problems. I'm going to do either numbers 13 or 14. Okay, you can continue that on your own. Out of 13 and 14, it does not matter which one you guys choose. It's the same difficulty level. Which one would you like to do?
14.
14? All right, let's do 14 together. We're going to need a lot of room for this, so I'm going to open the Smart Notebook. Okay, let's take a look at 14 now. So for number 14, we've got a lot going on. 3 of your denominators are already factored. X minus 6, X minus 2, X minus 6. They're all there, aren't they? But the upper left one is not factored. So I might want to start by factoring it into, which happen to be the other factors, don't they? Remember, use your surrounding denominators as context clues. So remember, please, start this problem by rewriting this denominator. Rewrite that denominator as x minus 6, x minus 2. And what you'll notice is that that denominator in this case does not have any effect on the problem. Okay, the other ones do, and we'll discuss that. So this becomes x minus 6, x minus 2. And now I need to see what's missing in everything.
Yeah, in the left
Well,
one.
Good, you go.
X minus 6 is missing on the left one.
Well, what left? Upper left, bottom left, what?
Bottom left.
Thank you. So x minus 6, slow down, is missing in both of these cases. I know that it's missing because my general denominators are either x minus 6 or x minus 2.
Isn't it the top when you're supposed to like, there's a minus sign here, not the minus sign.
We'll get to that. We'll get to that. You don't have to do it right now. But you can do it in the beginning if you'd like to, but I'll get to that in a second. Here, what's missing with the x minus 6? X minus 2. And what's missing down here? Just x minus 2 again. Now, I highly suggest that you put any binomial in parentheses right now, because a lot of you will forget to FOIL this stuff. That's it for now. The denominators, again, don't matter. Now, at this point, for this kind of a problem, we discussed y in class. I'm not going to go over y, but what we can do next. If they're all the same, it doesn't matter, because every denominator is the same now. So it's like saying that I have a common denominator up top of x minus 6, x minus 2, and a common denominator down below of x minus 6, x minus 2. So because it's on the bottom and the top, I can cancel. When the last concept, I didn't have a bottom and a top there. So I couldn't just cancel that. So remember, it only works this way because of that. What am I left with? X minus 6 minus, good, the minus, remember the minus. Yeah, we're going to get there. Up the bottom. No, yes, does that make sense? Sorry. Again, it's x minus 6 here, minus the quantity x minus 2, x minus 2. X minus 6 times the 9, don't forget the 9, plus
4.
Okay, well, you know what I've been noticing people do at this point? They start to cancel. You can't cancel yet, because again, you have add-ins. Stuff is being added or subtracted. You can't just cancel the 2's or cancel the 6's. It doesn't work. So you need to FOIL here. FOIL and combine like terms.
Are you supposed to have the opposite?
Well, at this point here, Eddie, that's what I'm going to talk about next, okay? I'm going to make this adding, but what's the opposite? I have to put a -1 there. That's where it's going to get tricky. So I'm going to hold off for a second, okay? All right, so here we get you have to remember your multiplication tables, guys. 9 by 6 is 54. I almost screwed that up myself. Here, now I look and say, okay, now I've got all adding and subtracting. There's no multiplying left anywhere if you look. The only thing that really is multiplying is the fact that this is a negative. When I see this negative here, what I really need to think about is that I'm really adding the opposites. So make this negative, really, this negative that was here, make it a positive and add all of the opposites. So switch all of your signs now. Okay, so the blue is what is really the signs. This was a negative, I made it a positive, and I made that negative into a positive, made that positive into a negative. Because you're adding all the opposites. Let's combine like terms. I've got a negative x squared up top. I've got, now notice like terms. This is a positive 1x. This is a positive 4x, giving me a positive 5x. In the last part, I've got a negative 6 and a negative 4, yielding negative 10. Again, I'm combining like terms, combining. In the bottom, I've got 13x minus 62. Okay. There is still a chance something can factor. So you have to try and do this. And let me show you exactly how to do this now. This is a little bit tricky. The denominator. Can 13 go into 62?
Yes. Yes.
Yes or no? Which one?
No.
Yes.
No.
13 times 5 is 65. So 13 will not go into 62. So right away you're actually done, even though we're going to try it anyway. But the bottom you can't do anything with. Again, the bottom you can't do anything with. So really you're done already. But up top, here's what I want to show you up top, a little trick. If you take out a negative 1 up top, everything becomes the opposite. The reason I'm showing you that is because a lot of people, when they see a negative x squared, they forget how to factor. Just take a negative 1 out and then try and factor. Clearly here, it doesn't work though. Nothing is going to multiply to 10 and add up to negative 5 here. So you're actually done. So if you had left it like this, or if you have it like this, or, yeah, I mean, that's pretty much all you can do. There's no way to factor what's left up top, but remember, if you have a negative x squared, there is a chance you could still factor. You take out the negative 1 here, and it's still there, it doesn't just drop off. You take out the negative 1, and you switch all the signs, and then try and factor this. But clearly, I can't factor that. It doesn't factor. So I'm done with this problem.
Wait, so what do you do with the numerator there? Like, how do you...
I combine like terms. I have an x and a 4x, giving me the 5x in the middle. I've got a negative 6 and a negative 4, giving me negative 10. And I've got a negative x squared with nothing else here, so it's just negative x squared.
Oh, but I thought you can't do it because it's in a parentheses and stuff.
It's not though, it's not. Okay, once Eddie told us to switch the negative into a positive, the parentheses are no longer there. So this is like having, remember? Like that now.
Alright, so it gets rid of it.
Okay.
Yeah, I see.
Last one. This is the one you missed. That's why I'm making sure you stay for this one. It's the last 2 days you're out.
So we're not going to do any writing today?
We're not doing anything new today, no. Tomorrow we're starting 43. Okay, tomorrow we're starting 43. Last one. We got, I'll put it back up at the end, okay? Just remember at the end. Out of 15, 16, or 17, what do we got?
About 18.
Is there 18?
Yeah.
Oh, wow, never mind. Out of 15, 16, 17, or 18?
18.
18?
Yeah.
Okay. I think that's an easy one, but all right, we'll do that. Out of these ones, though, I think 17 is harder than 18, actually.
Alright, 17.
Only reason 17 is harder is because people forget to factor out the GCF here. What comes out of p squared plus p? Just the p comes out. P times
Wait, what?
p plus 1. Let me show you here. Rewrite this like this, please.
I'm going to drink a water.
Okay, please start by writing it that way, because then you'll realize that all you're missing on the right one is p. You're missing a p here and up top. That's what you're missing. You are not missing anything else. If you look at it this way, though, it looks like you're missing a lot at first. Okay, now that the denominators are the same, what can I do here? Cross out. We'll do number 18 also, by the way. So we cross out my denominators. The only reason I can cross them out is because it's an equation. Who remembers the example I used in class? Melody and Diana, what was the example you got? The pairs. If you got the same thing on each side, and you cut them both in half, or if you divide it by the same thing, it has no effect on the problem. So I'm left with that's what I'm left with. All that's left is what's up top. Remember, it's a minus. Don't forget that minus sign there. Now it's a quadratic. You're going to have to solve. It's a quadratic. You need to distribute the p. So you're going to end up with, on the right side, okay, that's what I'm left with. But now since I'm subtracting it, what do I have to really do?
Add it.
Good. Add the opposite. Add the opposite. So what this is really saying is 1 minus p squared, or 1 plus negative p squared. So 1, make that a plus now. This is going to be a negative p squared and a positive 6p. I'm going to put it in order. And then what should I do with the p plus 5, guys?
Minus 5.
Okay, and next? Keep going. Subtract the 5, and then what do you do after that? Subtract the p. How come? What do you want on the left-hand side here?
0.
You want to get a 0 because it's a quadratic. When you have a quadratic or a cubic or a quartic in an equation, you're really finding the roots. To find the roots, it's called the zeros of the function. The roots are zeros because you need a 0. So get the p and the 5 over to the right-hand side. Subtract p, subtract 5. Subtract p, subtract 5. Do it all at once. You get a 0 equals negative p squared plus 5p minus 4. Now, remember what I showed you guys a minute ago? When you have the negative p squared, what did I say to do to everything? Good. Take a negative 1 out and switch all the signs. Okay? Take it out and switch the signs, please. Can you factor this at all? Does anything multiply to 4 and add up to negative 5? Negative 4, negative 1. Continue this over here, please. So what will your roots be then, by default?
1 and 4.
1 and 4. Does the negative 1 really have any effect on this problem?
No.
It doesn't whenever you're finding the roots. Remember, if you're simplifying, it does have an effect. But your roots will be 4 and 1. Now, the next question becomes this. Are 4 and 1 okay? How do I know whether or not they're okay as answers? 2 ways. Give me one of them. Check it in what? Good. So check in the original. That's one way. So you check 4 in the original and check the 1 in the original. What's the other check I need to do?
P cannot equal negative 5 and P cannot equal.
Okay, you're close, but you're not correct. Look at the denominators, not the numerators. You looked at the numerators, Karen. Remember, guys, our domain is restricted because of the denominator. What can the denominator not be?
Negative 1.
It cannot be
0.
0. Be careful there. 0. So what would make this denominator 0 if p equaled what?
Negative 1.
Negative 1 is one of them. Good. What else? There's another one. So p cannot be negative 1 because of this right here. That would make that one 0. What would make this denominator 0, though?
0.
Would it? 0. Guys, please listen. This is all about tomorrow, too. What we're doing right now is tomorrow's entire lesson is based on the denominator alone. Here, p cannot be 0 because 0 plus 0 is 0. Or because, look at the factors, please. Look down here. The factors are p plus 1 and p. If p equals 0, this would make the whole denominator 0. If p were equal to negative 1, that would make this part 0. So those are my restrictions. But my answers are not negative 1 or 0. So they're both okay. So what I have to do next is take both those answers and check them in my original. I'm clearly not going to get to number 18, so let me check these. So I'm going to check these in the original problem. So 1 and 4. Remember 1 and 4, please. We have to check both, yes. I'm going to check them in this original here. Okay, there's the original. I need to check two things. I need to check 1 and 4. Okay, 1 and 4. So in the original, it's going to be a little bit messy. 1 will be a lot easier because it's 1 squared, which is just 1. Okay? That's when I check 1. That's what I have there. I'll go through the numbers in a minute. And then 4 is the other one, right? I'll do this silently. Check it on your own as I go through it in your head, please. I'm going to keep writing. So these are my 2 checks. On the left, we're checking P equals 1 to make sure that's right. And on the right, we're checking P equals 4. If you want to, go to your calculator, type it in, see what you get. I'll do it for you, though. This becomes 6 over 2. The side becomes 3.
Prepare for our afternoon dismissal.
Again, this is 6, this is 2, that's a 3. 1 over 2 here, this is really 2, is 1/2, or 0.5. This will become a negative, so minus. This is going to be
Students, please report to Mr. Blanco's office.
negative 5 over 2, which is negative.
Martha Alvarado, Ruben Contreras, Danny Martinez, and Jose
Negative, negative
Miguel.
is a positive.
Following students should see Ms. Robolo, Iffy Marshall, and Emmanuel Amogbo. Joshua Kearney,
Right, that
please
is correct.
see Ms. Bondanella.
Next.
The
This is a
following
lot more
students
messy.
should see Mr. Chappa in CWSC.
That's a 9.
Donovan Fowler,
That becomes a
Christian
20.
Blackman, Juwan Moore, Juan Johnson,
Moore.
Maria Fernandez, Gabriel Bordado, and Sergio Trujillo. Those students who
Okay,
achieve
that
the honor
becomes a 1
roll
over 20.
and/or perfect attendance for the second quarter and first semester should come see Ms. O'Connor after school to pick up your award and free order from Domino's. Congratulations! Keep up the good work, ladies and gentlemen.
Now, this does
Just a
work.
reminder, the book club will meet this Thursday at 4
Common
p.m. in the
denominator now.
library.
I want a 20,
We
don't
will
I?
finish our
Yeah.
current book
So I
and
multiply by
discuss
4 over
plans
4?
for the book club field
What does
trip.
this make this?
Thursday, Jordan Lyle.
1
and
minus
Nancy Leon.
negative 8
Please
is
see
1
Ms.
plus
O'Connor
8, which
after
is
school.
a 9. Look at your numerators now.
You want to be up close and
The denominators are all 20. You can drop them all off, like
Well,
we've done
tickets for Don
before.
Bosco's second annual fashion show
9
will start
equals
to go
1
on sale this
minus
week for $10.
Negative 8,
Get them now because tickets
Okay.
will not be
which is
sold
1
at the
plus
door.
8, which is 9.
By the way, practice
They
will
both
still
work.
be held at 4:15
Is that only
in
one?
room 103. Don't be
Okay,
late.
I'm running.
And no unexcused tardy. Be a part